Anna is the owner of a Greek restaurant and she wants to expand her facilities. Though the facilities of a restaurant are, for example, the size of the kitchen, the equipment used in the kitchen, and of course the space to serve the customers. And she has two options. She can either invest today in a large facility, and then she takes the risk that the expected demand will not materialize. Or, as an alternative, she can expand now at a smaller scale, have a smaller facility, and in 3 years she reconsiders the situation, and if it's proper, she can expand then in 3 years again. Though she expects that the demand will be high with a chance of 70% and low with a chance of 30%. The large expansion today will result in profits of 300,000 Omani Rial only if the demand really materializes as high. And it will only be 50,000 Omani Rial in profit if it turns out that the demand is low. If she expands small today, the profit will be 80,000 if the demand is low. If she expands small today, but the demand actually is high, she can decide again in the future, in 3 years, if she should expand again, then this would lead to a profit of 200,000 Omani Rial. If she decides to not expand, then in 3 years, the profit would be 150,000. Now let's try to draw a decision tree and formalize this decision situation. We start from left to right. Though the square represents a decision point. The decision point, a point in time when a decision is made, is represented by a square. And we have two alternatives from this decision point. Either we expand small, and the other alternative is expand large. Both alternatives are mutually exclusive. We cannot do both at the same time. So if we extend large, then the next thing is that a chance event occurs. A chance event is a circle with some probability of an event happening. Though the probability that the demand is high is 70% according to the text. And in that case, the profits will be $300,000, or in the text we talked about Omani Rial. In the picture it's dollar. Okay, but don't bother about this. The other chance event is that the demand will materialize as low, and the chance for this, the probability is 30%. 70% plus 30% is 100%. The profit for expanding large and actually the demand is low will be $50,000. We could have more chance events, 3, 4, 5, not only 2. However, the probabilities should always add up to 100%. Okay, let's consider the other alternative. Today we expand small, and then it turns out that the actual demand was low. We again have a chance event, and the profit will be $80,000. The other chance event is that the actual demand is high. Though we expanded small, but the actual demand is high, then in the future, in 3 years from now, we have decision point number 2, and now we know that the demand is actually high, and we can make the decision to expand further which will result in profit of $200,000, or we can make the decision to not expand, which will result in $150,000. Now, how to solve it? How do we solve the decision tree? We solve the decision tree from right to left. We have been drawing the decision tree from left to right, and now we choose the opposite direction from right to left. Now we calculate the expected profit. Let's go for the expand large option first. So with a percentage of 30%, we make a profit of $50,000, and with a percentage of 70%, we make a profit of $300,000. So the expected profit, if we decide to expand large, is $225,000. Therefore, we have the lower branch. We completed these options. Now let's check for the upper branch. For the point in time 2, we do not have any following chance event, because in the future we already know the outcome of the demand. The demand already has materialized, though therefore there are no probabilities. And of course, when we expand, we can make a sure profit of $200,000, and if we don't expand, we only make a sure profit of $150,000. So therefore, of course, we decide to expand, and we write here the expected profit of $200,000. This $200,000 will be materialized with a probability of 70%. So again, 0.7 times 200,000, and the $80,000 profit will materialize with a probability of 30%. This gives us an expected profit of $164,000 for the branch expand small. So now we have two decisions to make. Expanding small results in an expected value of $164,000, and expand large has an expected value of $225,000. Therefore, when we follow the decision tree approach, the decision we should make is that we expand large today because it has the highest expected value. You can see these calculations again on the following slide. We go from right to left through the decision tree. We calculate the expected values, write them below the circles, and in the end we select the alternative with the highest expected value. The calculations are done here again, and this is the way we solve the decision tree. This is the way how we can use a decision tree to analyze sequential and interdependent decisions under uncertainty. Of course, keep in mind the decision tree will also be useful for other decision-making situations that are not related to capacity expansion decisions. So to sum up, we introduced different types of capacities, in particular design capacity and the effective capacity. We discussed the effectiveness of capacity. We introduced economies and diseconomies of scale. And finally, we introduced the method of solving a decision tree in order to solve interdependent decisions under uncertainty.